Hello everybody, welcome to our session. Today we'll be talking about AI. Unfortunately, we are talking about security. So today we'll be talking about fTPM Trusted Services implementation in the IoT platforms for Arm. This is Gökhan Gökçe and my colleague Devraj is over there. Just a quick introduction, who we are and what we are doing. Myself is a software technology manager working for Arm, more than 15 years experience in the market. And I have the IoT and mobile expertise with the entrepreneurship background. In Arm also I'm responsible for 2 projects, and one of them is IoT Edge, which is creating a kind of great collaboration with Linaro guys. And again, contributing to joint product roadmap with Linaro.
Good afternoon, everyone. I'm Devraj Danganna, and I've been with Arm from past 10 years working on Cortex-M and Cortex-A based reference solutions for IoT. I've been working in embedded engineer for almost 20 years, and working on wide variety of domains like process automation, IoT, and automotive. And I've been fortunate enough to get opportunity to work on different layers, almost all layers of software stack on both secure and non-secure sides. And also I work with Gökhan on contributing to the joint roadmap, product roadmaps with Linaro.
Great. So today's agenda is this. I don't want to give the all topics to you, but step by step we will explain what we are doing and how we are doing. And most of the technical parts will be explained by Devraj. Also, there's another session about fTPM SP. So this is from Balint in the afternoon.
Yeah, just the next session in probably one of the meeting rooms.
So you can get more technical information over there. Thanks, Balint. So what we are doing. Basically, in IoT Edge team, for the last 4 years, we developed a really sophisticated CI and even more complex than that. It's a special system called Cassini. What Cassini is doing is it's helping you to create a minimal OS image, plus it's a sophisticated CI, plus it helps you to get the certifications, plus it gives you some opportunities about integrating the native cloud solutions. So Cassini is donated to Linaro now. That's why we are working with Linaro in a really, really deep collaboration. And Cassini is just a component under Linaro's OneLab. I'm sure you all have checked the OneLab and you know what's it, but I highly recommend to check OneLab and all the features over there. So some of my team members are also member engineers and working under Linaro umbrella. And it's a kind of joint effort to enable the ecosystem, and especially about the ARM-based platforms and the security features. So, security is a really, really big topic. So ARM is always enabling most of the security solutions in the market. The 2 topics that most we are interested in are PSA certification and now Firmware TPM 2.0. Already our members did the integration for fTPM TA version for the KV260 platform. It's already available in Cassini software stack. The next step is we will be enabling fTPM Trusted Services support. So this is our goal, and then we'll be talking about it in more details. Let's see if I can show you a bit more. So what's fTPM? As you know, I'm just a technical product manager. I can't tell you all the details, but I can give you a really basic information about fTPM and the business deal behind it. So it's basically firmware-based implementation of TPM 2.0. It runs inside the Arm TrustZone. You don't need a separate chip. Basically, it's cost-effective, and it's ideal for IoT and cost-sensitive devices. And while we are doing this fTPM Trusted Service integration, so one of the goals is, it must be 100% API compatibility with the fTPM TA, and it must be proper implementation. fTPM SP is full support for the Trusted Service framework in the background, and upcoming all of the ARM platforms will be using fTPM SP. That is the important point for us. Another situation is U-boot and EDK2 based software stacks are already available under Cassini. That makes it also available under OneLab. So we'll be also supporting fTPM SP in our software stacks. I think that's the part that I'm just switching to. Devraj. So you are the technical expert. So take it. Thank you so much.
Thank you, Gokan. Cool. Yeah, Gokan talked about what is fTPM and what is fTPM SP. Now let's have a look at why fTPM SP. As Gokan mentioned, we already have fTPM TA, which is built on OptiOS. Since fTPM TA is built on OptiOS, T-client API needs to be used for communication between normal world and the secure world. In addition, the fTPM TA cannot utilize the services from the secure partitions implemented using the trusted services framework. However, fTPM SP can, however, with fTPM SP, FFA can be used to communicate between the normal world and the secure world. And also, fTPM SP can utilize the services from secure services, secure partitions, which are implemented using trusted services framework. ARM 8.4 introduced secure EL2, which is virtualization in the secure world. And the Hafnium is the secure partition manager core reference implementation based on the FFA specification, and Hafnium runs at secure EL2. If any of the ARM platforms support secure EL2, then fTPM SP, which is running at secure EL0, can work with Hafnium running at secure EL2 without the need for a trusted OS running at secure EL1. However, if any of the ARM platform doesn't support secure EL2, then fTPM SP is flexible enough to run on trusted OS running at secure EL1. To summarize, based on the platform capabilities, fTPM SP can either run on Hafnium running at secure EL2 or OptiOS running at secure EL1. fTPM SP is based on Microsoft TPM reference implementation, and MSTPM has its own crypto backend. In the initial version of fTPM SP, we have replaced the MSTPM crypto backend with MBTLS crypto backend, and there is also an ongoing investigation to support PSA crypto. However, there are some challenges identified by the trusted services team. Belent would be talking about fTPM SP implementation and also those challenges. If you're able to integrate the PSA crypto backend into fTPM SP, then we are also looking into delegating both PSA crypto and PSA storage operation to runtime security engine for improved security. And last but not the least, having more choices to implement fTPM on ARM platforms is always good. Partners can choose the right solution based on the requirements and the platform capabilities. So now let's have a look at different components involved with fTPM SP. So we have TPM2 tools running at EL0. So TPM2 tools is a comprehensive set of integration tests which ensures that the TPM commands like random number generation or key creation or NV storage or attestation are fully supported and are compliant to the TPM 2.0 specification. And also TPM2 tools is very generic, and it can be used with either a firmware TPM or a discrete TPM. And DN0138, just TPM command resource buffer interface over FFA, is a specification defined by ARM, which covers how to transport the TPM command resource buffer interface over FFA. And we have a new kernel driver called TPM CRB FFA, which has been upstream to Linux kernel, which implements the DN0138 specification. And yeah, there's also an optional hypervisor running at TL2. Then we have trusted firmware TFA running at secure EL3. Apart from loading all the firmware components and also the BL33 bootloader, TFA provides runtime service and also is responsible for managing the communication between normal world and the secure world. And then we have Hafnium running at EL2, which provides the virtualization support. Based on Hafnium, fTPM can run at EL0 and then without the need for trusted OS running at EL1, or fTPM can also work with trusted OS running at secure EL1. Now let's have a look at one of the TPM commands, how it traverses through this software stack. For example, TPM2 get random, which is basically a TPM command to get the random numbers. So TPM2 tools issues a TPM2 get random command, and then the FFA TPM CRB FFA driver would initiate FFA direct message and also update the CRB structures in the memory, and then the FFA ABI would invoke an SMC instruction, which would cause an exception to be taken to EL3, and TFA handle that exception. And based on the platform components and platform, either TFA will deliver the message to fTPM SPR either through Hafnium or through trusted OS. And once it reaches the fTPM SP, the fTPM SP would interpret the FFA message and also parse the TPM, the CRB structures in the memory. And to identify the command, once it identifies that it's a get random command, it would use either, if the PSA crypto supported, then it would use PSA get random to get the random number, and then it would update the CRB structures in the memory and also send the response back or FFA. Now, we have runtime security engine shown on the right side of the slide. So the runtime security engine is running on a Cortex-M MCU, and it provides PSA APIs, and it's connected to the AP through MHU. And also, that's not what I wanted. Right. So we also see an SE proxy SP in the secure world on the AP. So SE proxy SP is responsible for delegating the PSA requests from AP to the runtime security engine, and then get the response back. So on Corestone 1000 in Cassini on Corestone 1000 platform, we have a secure enclave, which is a Cortex-M based based on Cortex-M, and the SE proxy would delegate all the requests to that secure enclave. If we consider the same example, then of TPM2 get random, then when SP is supposed to get the random bytes, then it would use it would issue a PSA crypto get random API, and then SE proxy would delegate that to runtime security engine, get the response back, and then it traverses back to the TPM2 tools. Now, let's look at the validation. So, as I explained before, TPM2 tools is a comprehensive set of integration tests which ensure that all the fTPM SP is compliant with the TPM20 specification. So the TPM2 tools integration test would be running in the CI. And we have Greengrass integrated in Cassini, and we run the Greengrass IDT test in the CI. Greengrass uses PKCS11 APIs for crypto operation, and TPM2 PKCS11 provides PKCS11 implementation using the TPM2 APIs. The plan is to use keys needed for device identification to be generated using fTPM. And also, last but not the least, the TPM2 OpenSSL. The TPM2 OpenSSL provides OpenSSL provider implementation using TPM2. So, and also provides test. We're going to add that to the CI. Also, there are a few topics for further investigation, like measured boot and fTPM provisioning. So, measured boot is the process of securely recording and storing the hash of firmware components in the configuration data. So, we're going to investigate further on the measured boot, and then provide an example on Cassini. And with respect to provisioning, TCG doesn't, FTPM, the TPM provisioning is not part of TCG specification, but TCG provides a recommendation. So we'll have something similar in Cassini as well, like a recommendation. So yeah, now we have seen what fTPM SP is all about. Let's look at when it will be available in Cassini. So as Gogan explained, we already have fTPM TA available right now, and KV260 is a supported platform. And probably early, the late second half of 2025 or early second half of 2025, we should have the initial version of fTPM SP released on Meta Arm. And that would support base AM FVP. And sometime in first half of 2026, we'll have fTPM SP enabled in Cassini for both Coast 1000 and KV260 platforms. And finally, by second half of 26, we should have fTPM SP support for all upcoming ARM reference platforms, and also support for measured boot and capsule update and few more. Right, so now the availability on Cassini and OneLab, as explained in the previous slide, fTPM TA is already available in Cassini, and fTPM SP would be available sometime either end of first half of 2026 or early second half of 2026. So all the platforms supported in Cassini are also part of OneLab. So as soon as we have fTPM SP solution available in Cassini, it would be available in OneLab as well. So partners can run the TPM test suites and also experiment with measure boot and look into fTPM provisioning recommendations. Cool. Any questions?
The reasoning for this fTPM SP project was that you could reduce costs because you don't rely on secure or on other chips. Yet you said that you are delegating the crypto and storage to a secure enclave chip anyway.
If the platform as already contains a runtime checker engine doesn't only provide it's not only used for delegating the fTPM PSA request, but it has other features as well, like it provides all the PSA implementation, and it's effectively kind of is root of trust of the system. So it's that's why.
So it's a part of IPs that it's already in the SOC. So I was talking about you will not have the separate chip, that you will be designing extra PCB or something like this. So that was the interesting part. So basically, I mean, I can't tell you the exact numbers, but overall, if you are doing a production more than 1 million units IoT boards or something like that, you can save really good money.
Okay, gotcha.
Thank you. Anyone else? Yeah, go for it.
So, thanks for the presentation. I'm wondering, so you told us for Corstone 1K platform that the state of the fTPM is stored in the secure enclave side, basically, ultimately?
Not the state, it's, when you say state, what you're referring to, is it?
Secured private keys, I think.
Well, with the fTPM, I think
Yep.
you need to generate some private keys at some point, so those keys needs to persist across reset, and
Yes.
so those keys, I understand, are stored on secure enclave storage side in the case of Corstone 1K, if I understood correctly?
Yeah, so there is a provision that it is possible. So currently there's an ongoing investigation to support PSA crypto in fTPM SP. And so that would be possible only when we have that integration ready.
Okay.
So if that's, probably Belen will talk more about that, but
okay.
If that's not feasible, then it would be in the AP itself.
Okay, so that's the second part of my question, more or less. I was wondering on the AMD KV system, where are you storing that storage if there is no secure enclave on that system?
So with the, it would be on the AP itself. So currently it's using one of the PSA storage secure partition on the AP.
No, but it doesn't have flash or anything. Where do you do the secure storage?
Is that eMMC RPMB maybe?
Right, so yes. So, this, it still need to be discussed, looked into further, but there is a possibility of having, so I think Opti provides RPMB backend, so that can be used for storing, but it's still being looked into.
Okay.
So, but currently, it's using the PSA storage API for all the storage necessities, including the NV storage as well.
Right, thanks.
So.
Any other questions? I think there's no more questions. Thank you so much.
Thanks,
everyone.
everyone.
It's a great experience. Thank you.